Hello everyone, welcome to today's presentation about flipped learning and the flipped classroom. I really hope that what I have to say today will be useful to you and that you will think seriously about whether this relatively new and interesting approach to teaching and learning has something to offer you personally. What I have to say is not just theoretically. I flipped a classroom myself back in 2010 when the term was so unusual that I didn't know about it myself. I was at that time calling what I was doing the inverted course. So I hope what I have to say will be of interest because it is based on practical experience with the methodology. I'll be able to talk a little bit about the history of my own experience and discuss how that's changed my teaching approach and how it's impacted on the student experience. But let's begin with the simplest possible description of what the flipped classroom involves. The flip we're talking about is an exchange between what traditionally we have done synchronously in the classroom, typically lectures, and what traditionally has been done asynchronously by students outside the classroom, typically at home or in small groups, learning groups of peers. Why might we be interested in flipping the classroom? Well, the main idea is that by doing so, we also flip the learning too. Here is a definition from the Flipped Learning Network. As you see, flipped learning is a pedagogical approach in which direct instruction moves from the group learning space to the individual learning space, and the resulting group space is transformed into a dynamic interactive learning environment where the educator guides students as they apply concepts and engage creatively in the subject matter. The key part of the definition is the possibility of transforming the time that students actually spend with their teachers. Let me explain this a little more with reference to the course that I taught myself. The course was an advanced course in software science, an area of computer science, a topic which is essentially mathematical. It was taught at the University of Essex in the UK over 10 weeks in each of 6 consecutive academic years from 2008-9 to 2013-14. With no substantial change to the learning outcomes or the syllabus. While a practical course in computer science might be expected to change more rapidly, the principles underlying the course, being fundamental, didn't change very much. It'll be important to note that this course was an elective. It was an option in the curriculum. Thus, students who take it were making a positive choice. During the academic years 2008-9 and 2009-10, the course was taught as a traditional mix of face-to-face lectures of 2 hours a week and a tutorial class of 1 hour a week. And then during the years 2010-11 to 13-14, the course was delivered according to various incarnations of the principles of flipped learning. And for those 4 years, the lecture material was delivered asynchronously through vodcasts, video lectures, and consumed by students individually and off-site at a distance. The amount of contact time with me, the instructor, that didn't change. It was still 3 hours a week, but now all of these were face-to-face tutorial classes. These tutorial classes involved students in undertaking exercises, discussions, problem solving, either individually or in groups, with academic support from me, the teacher. This approach then tripled the amount of time that students and I had together to be able to work on problems, discuss issues, overcome difficulties, and generally get seriously into the practical aspects of the material. What disappeared were the much less interactive lectures where the fundamental material was previously delivered. If this tripling of the class contact time was the only benefit of flipping the classroom, I think I'd have been pretty happy. But there turned out to be a great many other benefits that were not so easily anticipated. I'll come back to these in a moment, but first, let's take a quick look at the history of flipped learning. In some form, the idea has been around since about the year 2000, and it began in primary and secondary education, not at the tertiary level. It took about 10 years for the idea to mature. In part, the reasons for this slow start were technical. This approach relies on technology, and that technology was simply not available 15 years ago. And even when I started my own experiments, I faced considerable challenges that became much, much easier to overcome with the passing of time, and now are simply not challenges at all. I think it's particularly important to note that while technological support is essential for this approach to work, this is a case of learning supported by technology and not a case of new technology, in search of novel pedagogic applications. Anyway, there's no point now in discussing the technical difficulties that teachers faced in the past. If you want to get involved, the technological barriers are now very low, and I'll talk about them later. Let me return to my own experiences and my discovery of the additional benefits for teachers and learners. First of all, my experiments began with the assumption that the 1-hour lectures, as presented in the normal face-to-face lectures on campus, would be videoed in their entirety so that the student experience would be the same as the face-to-face delivery. But I soon realised that the technology offered new possibilities, and that our idea of 1-hour lectures was really the result of constraints that simply don't apply when students are not synchronously attending real-time events, but are asynchronously engaging in a virtual non-real-time event. Simply put, the 1-hour lecture is not a pedagogical but a practical decision. If we have to get teachers and learners together in real time, there's no point in doing so for a few minutes. Something like an hour is essentially the shortest period of time that it makes sense to create workable timetables and to distribute the working day of teachers and students alike. So as a result, material has to be stretched or shrunk to fit into these 1-hour slots. In contrast, a virtual event requires little overhead for a student to attend. They don't need to travel, they don't need to fit in with somebody else's arbitrary timetable. As a consequence, it wouldn't matter if the lecture was 3 minutes long or 30 minutes long. And this is a massive win for both the teacher and the student alike in another way. Because suppose as a student you want to learn about a small subtopic from the middle of the course. Can you remember whether it's in lecture 5 or 6 or 7 in order to seek out the relevant material? As a result, the 20 1-hour lectures became 54 educational segments of varying length, designed around individual and specific topics. These varied in length from a few minutes to about 20 minutes. And since each segment was a named topic, it was very easy for students to locate a subject that they felt they needed to give more time to look into more deeply. I'll give you an example from the very beginning of one of those segments. These are what the students look at instead of the 1-hour campus lectures. Now we're going to look at a slightly more ambitious example. Let's consider a system which comprises a number of resources, some of which are in a live state and some of which in an idle state. And this then brings us to another really important advantage that students welcomed. They were able to watch these video segments as often as they liked. If they lost concentration during the first viewing, they could always go back and watch it again. And similarly, if they didn't quite understand something the first time, it was explained, they could just go back for another viewing. Of course, if they still didn't quite understand, they did have 3 hours a week of class timetable with me to ask and discuss their issues. But above all, students found the availability of the segments most useful when they came to revise for the examinations. In the UK, the gap between the course and the examinations is sometimes a matter of months, and an opportunity to refresh their understanding of the material was a major positive benefit. Well, by 2012, almost all of the technical challenges had been overcome, and I'd moved all the video segments to YouTube. And I'd embedded these in Moodle for the course as a whole. And at this point, it became possible to add new features to the flipped classroom that again students found of major benefit. One of these concerned their assignments and the coursework. Now, we all know the importance of high quality feedback in connection with student coursework. Well, I was able to provide general feedback and worked answers for assignments through video segments. Here is an example of that. It's feedback from the last of 4 assignments that the students undertook during the semester. An overview of the solution to assignment 4. A cooker has 2 hot plates controlled by 2 controls. Each control is on or off, and in order to prevent overheating, it is not permitted for both hot plates to be on at the same time. That's the background. And the stage 1 was to specify the local state for a single hot plate and to provide an introduction rule. The same was true for class and homework exercises. You'll see in the next video clip that the solution is done by hand. Students find nicely typeset mathematics very intimidating, and a strange observation to say that, but it's true. Even more intimidating is that they usually see the final results typed up in textbooks or in instructor worked answers. And because of this, I tended to provide handwritten solutions for them and to video myself doing them in real time. And by this way, they were able to see mathematics as a process of discovery and not as an encyclopedia of static results. All right, let's prove the law of the excluded middle. So we're going to prove that P or not P holds. So we need a proof of this. Now, how are we going to get this contradiction? Well, we'll contradict the assumption here, not P or not P. Okay, that's using this assumption here. And we'll contradict that with P or not P. And this one we now get by or introduction on the left, because we now have this as an assumption. And the proof is complete. At this point, it's probably worth spending a little time discussing the kinds of technology that's available for creating a flipped course, and to make some comments on the effort of getting the course up and running. As I mentioned earlier, it's infinitely easier to develop a flipped course nowadays. There are 2 software solutions that are wonderful and not very expensive and very easy to use. One or another of these is really essential for creating the video segments. One's called Camtasia. It's available for both Windows and the Mac operating system. The other is called ScreenFlow and is available for the Mac operating system. Both are excellent, and I use ScreenFlow for my course. Here's an image of the ScreenFlow application. What you see here is the video image at the top and the timelines below, which set out the video and audio tracks together with additional material like screen movements and text overlays. Don't be intimidated, it's really incredibly easy to drive. Another wonderful discovery I made related to the difficulty in rehearsing and recording a video segment. I had imagined that I'd have to take a really deep breath and get an entire 20-minute segment recorded correctly without any major mistakes. But ScreenFlow lets you glue together a sequence of smaller ScreenFlow files. So, in fact, you can make your videos slide by slide, just one slide at a time. And then you piece a set of individual slides together to make the entire segment. And since recording a single slide takes so little time, I found that I could sometimes fit 1 or 2 in between my other duties, which was really efficient from a time management perspective. It did, however, lead to some amusing continuity errors, which students found rather charming. Sometimes I would be in different places and wearing different clothes between slides. Sometimes I'd even be in a different country. So to turn this into an advantage rather than a disadvantage, I sometimes slipped in a slide about my location, like a photo and a description of a hotel in Ghana that I happened to be in once when I was recording. This saved a lot of time because if I made a mistake, it would only affect perhaps 30 seconds or a minute of recording time. Indeed, if the slides and the course are already mostly prepared, the overhead in creating a video segment compared to delivering the material could be as little as only 2.5 to 1, at least once you get familiar with the technology. That is, you can create 1 hour of video material in about 2.5 hours. ScreenFlow lets you up directly to YouTube, which saves some time in getting the materials online. And as time wore on, new technology became available that provided even more interesting possibilities. One of these is the LiveScribe pen. This allows you to generate pencasts, which are multimedia PDF files. What the student sees is you writing longhand, and the writing appears on the page alongside an audio commentary. Instead of returning student homework with standard red pen feedback, it was now possible to return a soft scan of the student's work with a real-time annotation and audio comments. Better still, the student can simply point at a place in the document and the writing and the commentary immediately begins at that point. Here is an example.
CE 304 Assignment 1 Exercise 1 P from P and Q or R assumption 0, and we get Q from assumption 1. On this side,
I now want to leave the technology and return to the pedagogy, in particular to discuss typical results of flipped learning and the impact on learning outcomes. And I'll do this with reference to the course that I developed and taught myself. As an advanced course in the curriculum, the learning outcomes of my course expressed competencies at higher levels in the Bloom or Anderson taxonomies. Students had to be able to write programs and specifications and to prove mathematical theorems, so analytic and synthetic cognitive competencies are required. To properly meet such outcomes, students have to practice them and not just be told about them. They are activity-based and benefit from real-time support. Such activities and support require time, something that was in short supply when the course was taught in the conventional manner, with only 1 hour a week for the classes. By removing the non-interactive didactic presentations from the face-to-face meetings, the time permitted for activity-based support for the development of these higher level skills was tripled. How did my students enjoy this experience, and how did this impact on recruitment to the course with each passing year? Remember that this course was highly mathematical and students typically find these courses hard, and if possible they try to avoid them. And since the course was an elective, it was an option, they could, if they wished, just not take it. Well, here are the results. The first thing to notice is that the number of students who opted to take the course increased even in the first year it was taught in the flip mode. This occurred during the add drop period as students learned that there was something interesting going on. The very small numbers of students on the course when it was in conventional mode increased dramatically in the second flipped year. Students had learned something from their older friends. By the time the experiment finished, the number of students taking the course rose to become more or less the total number of students in the cohort. Now, let's look at the results. I won't try to explain the UK's strange marking schemes, but suffice to say that the average mark rose from acceptable but below average for all other courses to impressive, well above average for all other courses. There were some other reasons for this in later years, because I introduced innovations in the assessment as well as the flip course, but I don't have the time to describe these in this particular presentation, and anyway, they're matters that are completely independent of flipped learning. I'm not a big fan of student assessment of courses, but here are some results from one of the early years of the flipped experiment. These are good indications that students were happy with the course. In this analysis, the middle value of the Likert scale was labelled neither agree nor disagree, and responses in this category were not used in the analysis at all. In addition, we had some written feedback from students. One student said, "I really liked the way this module was structured in terms of having the lectures as videos online, as that allowed us to replace and replay the parts of them that needed more attention and also for revision." Another student said, "I found the classes very useful, and overall I think this method of teaching has a good future and may benefit other subjects if other lecturers want to adopt the idea." Well, okay, I think that about wraps it up for this presentation. I think in conclusion, I'd like to highlight two areas for you to consider. First, this approach provides a means for improving the quality of the time an instructor can spend with the students. In deciding whether this approach is right for a course that you teach, it's a good idea to consider the current value of the on-campus lectures and what use you'd make of a significant increase in interactive time with your students. If, like my mathematics course, the lectures are not so interactive and the students struggle to find enough time to ask questions and to practice their skills, particularly with the instructor present, then the flipped approach may well be for you. Even if your lectures are highly interactive, it may still be a good idea to provide some of the material in video form, leading to partial flipping. As we've seen, there are many other advantages beyond freeing up time for interaction on the on-campus activities. Second, the technology serves to remind us that some of our traditional approaches, such as the 1-hour lecture, are not designed for pedagogical purposes but appear for practical reasons. There are many different ways to teach and learn that open up when the technology is embraced. These also are to a large extent independent of the nature of the course. Well, thank you very much for your attention in this course. It's been a great pleasure, and I hope you're able to make use of something that I've covered, and good luck if you do. There's also a published paper that accompanies this presentation, and if you'd like a copy, please don't hesitate to drop me an email. I'll be very happy to send it to you. Thank you.